Welcome to qnawire.
In this question, we are told about a cobalt hexa aqua complex that when you add hydrochloric acid to it, and of course it was red in color. When you add hydrochloric acid to it, it turns to blue solution with the cobalt tetrachloro complex. So we have to explain this color change. So what happened is that the red color, it absorbed at a wavelength of 490 nanometer, and the blue color absorbed at a wavelength of 600 nanometer. Well, this is reasonable because the cobalt hexa aqua is octahedral, and this is octahedral, right? This is an octahedral complex, and this is a tetrahedral. And the crystal field splitting energy of the tetrahedra is 4/9 that of the octahedra. So that makes sense because the energy gap for the transition, or the energy for the transition in the cobalt tetrachloro complex, will be smaller than the energy gap in the octahedral complex. And that will cause this to absorb at a longer wavelength because, energy is inversely proportional to wavelength. So the higher the energy, the shorter the wavelength. And then the lower the energy, the longer the wavelength. Because this requires less energy because of the smaller energy required in tetrahedral complex, which is 4/9 that of the octahedral. It will absorb at a longer wavelength, around 600 nanometer, which will cause it to be blue. So that explains why you experience a color change going from this red octahedral complex to this blue tetrahedral complex.